Okay guys, we are going to start chapter 2 PowerPoint. So you should have a blank one of these on your canvas, and I would suggest to go ahead and print this off and just follow along with the notes with me. We're going to also be doing some examples from the book, so whenever I print it out, I would suggest doing 3 PowerPoint slides to a page, and I can actually put a video on that can show you how to do that at some point. So you might already know, but just in case, that's what I would do if I was going to print it off for you. Alright, so this is my favorite chapter of the entire book. This is the most physics portion, I would say. It's all about motion, and that's my favorite stuff to go over in physics. And so obviously it's not going to be as in-depth as my other physics classes, but we are going to talk about the main points of motion, and there is going to be some calculation. So this is the chapter that has the most math, and if you're groaning right now, even though I can't see you, I can almost see you and hear you groaning about that right now. Don't get too discouraged. Just, we're going to get through it. And if you have questions, you can always email and we can Zoom, or we can figure out something. All right. So as I said, this chapter is about motion. And in order for there to be any kind of motion, there has to be a net force. It's required in order for there to be a motion. Just think about when you move your legs, your muscles are pushing against and causing a force. And if you didn't have that force, you wouldn't be able to move. All right, so any kind of motion requires force. So the definition of motion, it is a description and explanation with application. And there are 3 basic concepts of motion. So we're going to go through all of these. First is position. Oh, here we go. Position. Let's change color. Position, speed, and velocity, and acceleration. So we will talk about all of those concepts. Again, this is just kind of an outline, and more in depth. And then some applications of those 3 main concepts are sort of this horizontal motion, and we'll also talk a little bit about vertical motion, which kind of gets into this falling objects category, because if you think about it, if you drop something, which way does it fall? Well, it falls vertically, right? It falls down. And then there's compound motion. So it's like these 2 things combined. And I always say, think of like throwing a football. If you were throwing a football, it kind of goes like this. I'm terrible at drawing, by the way. It kind of goes through the air, and then it eventually lands, right? So this is going this way, but is it also falling? Well, absolutely. We threw it at an angle going upward, but because of gravity was constantly a force on this object the whole time that it was in the air. And because of that ball is going to fall. It's going to get to this point at the very top where it can't go any farther, because the force that you provided for it to go up is no longer as strong as that force of gravity. Okay? All right, so explaining motion. So that's kind of where we get into forces. We talked about how forces, you have to have that in order to move. We will discuss this term called inertia. It's kind of you've probably heard it before, but we'll discuss that and how that's related to mass. And then Newton's laws of motion. And those are very important. If you should leave this class knowing Newton's three laws of motion. Okay? And then again, it goes into these applications that we briefly talk about, such as momentum and impulse. And then we talk about circular motion, kind of like satellites or something orbiting. Think of it like that. Newton's law of gravitation and how things are attracted to one another. We'll go on a little bit further into that. And then satellites. Okay, so let's go on to this fundamental components of motion. All right, so there's two fundamental components. First off, there has to be a change in position. So, like, take this car, for example. That car is moving. How would you know that it's moving if it didn't have anything behind it? So think about when somebody's like running or a car is driving, you can usually tell that it's moving because you can see things behind it that are not moving, right? Those are that's called a reference point. So when those things stay behind, you can tell that the car has gone from one position to another. So there's a change in position. And then it also had to take a certain amount of time in order to do that. Okay, so in this case, it's saying that it went from 50 kilometers to 100 kilometers in a matter of 1 hour. Okay, so it gave you one position. This is like position 1. And this is position 2. And it also gives you how long it took to get from position 1 to 2. Okay. And so whenever you go to measure motion, you have to consider what that change in position is, what the time was that it took, and you can find all of these different things with those variables. You can find speed, you can find velocity. There's a difference. These are very close, but there's a small difference that we'll talk about. And then you can also find acceleration, which is it's different than speed, but we'll get into that here in a minute too. All right, so speed is equal to, I don't know where the equal sign is here, is equal to distance divided by time. Okay, now whenever you are given this equation, this is your first equation of this chapter. Whenever you're given this equation on the quiz or the test, it will not look like this. I won't give it to you in word form. I will give it to you in symbol form. So the symbol for speed is V, okay, because speed and velocity are pretty similar. It's the same equation. So it's V is equal to D over T. So thankfully, those symbols are the same letter as what the word starts with. All right, so speed is equal to distance divided by time. Well, whenever you're going to solve a problem, this is kind of the first step. And you know how when you're in math class in like middle school and you had to go to those end problems and they were the word problems and you hated those? Yeah, that's physics. They're all word problems that you have to read, and then you have to pick out the information and you have to find an equation that will work. It's simple algebra, or in this case, literally it's just division, but you have to figure out what equation to use. So we'll get into some examples to kind of show how to tell the difference between. But I do want to show you a little bit of algebra here, because you will not always solve for velocity or speed. Okay, sometimes you might have to solve for distance, or sometimes you might have to solve for time. So if that's the case, you have to do a little bit of algebra, but I'm actually going to show you a little shortcut. I just want to show you the little bit of algebra really quick. So let's say that I was going to have to solve for distance. Okay, so let me rewrite this equation. I have this sort of like a sideways slash. I'm going to write it like this. Velocity is equal to distance divided by time, where it's straight up and down. Okay, if I want to get that distance all by itself, what do I have to do? I have a fraction here. So number one rule, whenever you have a fraction, you got to get rid of that denominator right there, that time. So how do you get rid of the time? How do you get it to the other side? Yeah, you got to multiply. I'm hoping that you guys were answering me right there. So if I multiply time by both sides, what happens to these two times? They cancel. Sorry, all my texts and news and stuff is coming up on the screen. Okay, so those cancel. And so now you have time times velocity is equal to distance. And there we go. I've solved for distance now. What if I wanted to solve for time? So if you wanted to solve for time, you basically have to do this step that you just did. And then how would I get velocity over to the other side? If these two things are being multiplied by each other, how do I get this v over to the right side? I'm hoping that you guys are answering me right now. You would have to divide. And then that would end up canceling that. And so you end up with time is equal to distance divided by velocity. Okay, so if you're like flipping out right now, I hope you're not, but if you are, there is a little bit of a shortcut for equations that have 3 variables. So you'll like it. We do have equations that have more than 3 variables, so you will have to do a little bit of algebra in this class. This class requires pre-algebra, and you should know how to do at least this stuff before entering this class. So if you didn't like that, you can do this triangle, and you would put speed is equal to distance divided by velocity. So the velocity or the speed has to go in the bottom left, the distance has to go in the top, and then the time goes in the bottom right. So if you were solving for the velocity, like the regular equation, you put your finger over that v, and you see how it's distance, and then there's like this line right here, divided by time. So v is equal to distance divided by time. If I wanted to solve for distance, you put your finger over the d, okay, and see how velocity and time are right next to each other? It's like they're being multiplied. So distance is equal to velocity times time. And then same for time, you just cover it up with your finger and it's distance divided by velocity. So hopefully that makes sense. I'm going to stop the video here because we're going to go to an example here in a minute. So just pick up with me on the next video.